Howdy folks, it's Coach Primeaux here. I'm going to go over this review real quick with you. If you have access to your Schoology, it might be in your best interest to keep some of those windows open so you can look at the vocabulary list we have. I'm going to show you how I do that. Give me just a minute to pull up Schoology. Okay, so I went to ClassLink and signed in. I'm going to go to Schoology. It's this little icon right here. I'm going to click on it. It automatically signs in for me. My face will come up here in a second. Just give me a second here. There I am. All right, I'm just going to use second period as an example here. In here, you have AQR 1.1 vocabulary and AQR 1.2 vocabulary. Now, you probably won't need much off AQR 1.1, but you'll definitely need the vocabulary for 1.2. So when you go to do the review, it might be in your best interest to open these up. Have them ready. These are actually the word walls I have in my classroom. I just took pictures of them. Didn't want to try to reinvent the wheel. So there you go. You also need this other one. So I'm going to open up a second tab with the vocabulary list in there, and I'm going to open this one up too. And it's coming up. Now, just to be on the safe side, I'm going to go ahead and I'm going to open up another link, and I'm going to go ahead and open up these other two in AQR 1.1 vocabulary. The whole point is to have all my resources readily available to me so that when comes time to do this review, I have it all there, because you need your resources, okay? You definitely need your resources, okay? Let's go open up a new tab one more time and get the last picture of the vocabulary up in my room. So this goes in order. This is the word wall that I put up for the first part of the unit we went through. It defines graph, vertex, edge, loop, degree, Euler path, Euler circuit, weight, weighted graph, Hamiltonian path, and Hamiltonian circuit. It also goes over how to determine when an Euler path or an Euler circuit exists, and how to determine if neither exists. All right. In this one, let's go to the first one here. We discuss what a disconnected graph, connected graph, what a cycle is, an efficient network, and a minimal spanning tree. It was very important to know all these terms. Let's go further in the minimal spanning tree. I actually define each word, best way to describe how to use it, okay? And chromatic number, prerequisite activity, minimal completion time, and critical activity. So let's go to the review. Got the review up here somewhere. There we go. All right. So let's look at the first question. First question is and it has 3 blanks, is the shortest time required to finish all tasks in an activity graph, okay? So 3 words in a phrase. Shortest time required to finish all tasks in an activity graph. Well, let's look. I got 3 words right here. I don't think it's it. A subset of edges, of connected edge, weighed, undirected graph that has no cycle. No, I don't think that's it. Let's look at the next one. 3 words. There's only one: minimal completion time. Time to complete all activities in a project. Wow, that sounds about what it looks like. Shortest time required to finish all tasks in an activity graph. All right. Now, the graph that is and blank blank is one that has values assigned to the edges. Okay. Weighted graph, a graph where the edges have values assigned to them. That looks exactly like what we need. All right. Okay. Blank blank fall upon the longest pathway from start to finish in an activity graph, and if delayed, would delay the minimum completion time. All right. How about this one right here? An activity which, if delayed, would delay minimal completion time. That's exactly what that statement says. Critical activity. And in my class, I actually call the pathway that all critical activities are on the critical pathway. It's not in the book, but it just makes sense to give it that kind of name because, I mean, if all of the activities on that pathway are critical activities, why not call it a critical pathway, right? Fall upon the longest pathway from start to finish in an activity graph and it's delayed would delay the minimum completion time. All right, an efficient graph that is completely connected with the lowest sum of values on all edges is considered a or an blank, blank, blank. All right, so let's look at the vocab. Minimal spanning tree. Remember we just looked at that? Minimal is least, spanning is connected, and tree is no cycles. It's efficient. That means no cycles. So a minimal spanning tree is a subset of edges of connected, there you go, there's one word that helps you define it, edge-weighted, undirected graph that has no cycles and has the minimum possible total edge weight. I think that kind of fits the bill. Minimal spanning tree. A process that solves problems through a step-by-step procedure is called an. When you solve a Rubik's Cube, you use something. It's a pattern and step-by-step procedure to solve it. But a process that solves problems through step-by-step procedure is called an algorithm. All right, a blank blank is required before moving on in an activity graph. Before you can move on to the next activity, you have to find something that works there. Check it out. Look at this right here. It's an activity required to be completed prior to moving to the next activity. Required before moving on in an activity graph. That's exactly right. A prerequisite activity. You go on to college or you go on into trade school and you're taking courses, what you're going to find out is that there are prerequisite courses you have to take before you can take some of those higher level courses. Minimum number of colors necessary to color the vertices of a graph so that no two blank share the same color is called the, and there's two blanks. Let's take a look at our word wall. Chromatic number, least number of colors needed to color all vertices of a graph so that no two adjacent vertices share the same color. So that no two blanks share the same color is called the, guess what? I think we just found it. Vertices is the answer to this part. Now, you might say, but it's for map coloring. Why are we calling them vertices? Because we use a graph to model the map so that we can show those boundaries and how the colors have to be used a certain way. Minimum number of colors necessary is called the chromatic number. Where there is one less edge than vertices, a blank exists. Well, guess what? We already talked about that right here. An efficient network, a graph with just enough edges, one fewer than vertices. Isn't that what it just said? One less edge than there are vertices. That's exactly right. It is an efficient network. All right. Find the sum of the minimum spanning tree for the following graph by using Kruskal's algorithm. So I found Kruskal's algorithm, and I'm going to place it right in here. You're going to start with a table of weights associated with each edge. But we have weights on the graph already. So what I'm going to do is I'm going to list them from smallest to largest. The first one that we look at is AD has a value of 2. Then we have EH, which also has a value of 2. Then we have PE has a value of 3. BD, which has a value of 4. And then CG, which has a value of 4. EG has a value of 5. And also AC has a value of 5. FH has a value of 6. DH has a value of 7. And last but not least, BF has a value of 8. We have all of the 10 edges with their associated values listed from smallest to largest. Next step, find the smallest weight in the list and include the associated edge and 2 vertices as long as it doesn't create a cycle. Let's start with AD. I'm going to highlight it because we can use it. It doesn't create a cycle. AD, all right? How about EH? If I add EH, you only have AD and EH. No cycle is used, right? Or no cycle is created. I apologize. DE, in between AD and EH just makes a single line of edges. Okay, so we'll use it. Wish I could highlight it and make it so much more understandable. BD, even though you have ADEH and D comes out to B, it still does not create a cycle. Think about it from this perspective. If you connect that, B can connect to A only one way, through D. Now you say, oh, well, you can go to E and back to D. No, that's still B, D, A. There's only one pathway between B and A. All right? How about CG? CG is not even connected to it, so we can use it because you have to be connected to create a cycle. But in this way, CG is out by itself, then you have ADB and then DEH all together. All right? Now how about EG? If I put EG in here, is that going to create a cycle? You have all this. All it does is connect this little edge to the rest of them. So yeah, let's go ahead and add EG. We'll highlight that to signify we've used it. How about AC? Remember, we got ADEGC already. If we have AC, we have more than one pathway between A and C. So we're not going to use that. I'm going to highlight that gray. We're not going to use it, okay? How about FH? FH6 would connect the already connected path we have to the rest of the pathways. So we're going to use it. And it says here in this step, remove the weight from the list. We're removing it. I'm actually highlighting because I want to see this. Mark through it, just show you've used it. Something to show you've used it. And step 4 is repeat steps 2 and 3 until all vertices are connected. So all vertices are connected, A to D, B to D, D to E, E to G, G to C, E to H, and H to F. So there are no cycles, but you have a totally connected network. So what is the minimal spanning tree? What is the sum of the minimum spanning tree? Well, just add the numbers in green. 2 plus 2 is 4, plus 3 is 7, plus 4 is 11, plus 4 is 15, plus 5 is 20, plus 6 is 26. So the minimum completion time equals 26. Okay? All right, let's move on. What is a chromatic number of a graph that models the following map? Okay, what I have here is I started by drawing lines that I know reflect what the vertices or the regions look like. We're looking at this region. 1 touches 2, 2 touches 3, 3 touches 4. That's the square. 1 also touches 3, but 2 does not touch 4. So all we have to do now is to place the labels for each one of those vertices. And that's what I'm doing here. There's 1, there's 2, there's 3, and there's 4. So as you can see, 1 touches 2, 2 touches 3, 3 touches 4, 4 touches 1, and 1 touches 3, but 2 does not touch 4. So we can actually color these 2 and 4 different colors. So I'm going to color them yellow. Okay? But 1 has to be different than yellow. So I'm going to make it red. And 3 has to be different from red and yellow. So I'm going to make it green. Okay? So as you can see, this map right here, and I could actually fill in this map if I wanted to, but I'm not gonna, with those colors, and it would work perfectly. What is the chromatic number? How many colors did I use? The fewest number of colors that I need for that particular map is going to be 3. So the chromatic number for that is 3. So look at the next question. A graph that is a square with a node is another word for vertex, okay? At each corner, 1, 2, 3, 4, and a diagonal between node 1, top left, and node 3, bottom right. Let's look at it a little bigger so you can see it. All right. Model the map in question 15. Well, of course it can. I'm doing it right here. Consider that the prom committee has several members able to complete any of the tasks on the below activity list. Answer questions about the prom using the following chart, okay? We have 6 activities: purchase food, purchase supplies, prepare food, decorate dance hall, hire DJ, decorate school. So what is the first activity in this particular chart that has no prerequisite activity, and it's purchase food. So any activity that has no prerequisite activity has an arrow coming directly out of the start going to purchase food. Okay? We'll put the next one, which is purchase supplies. Let's go ahead, and I need to change this, move this a little bit out of the way. Purchase supplies. Okay, we got purchase food. Purchase supplies is the next one. We want to move it closer to start because it's going to be right out of start. Then we're going to create an arrow out of start going to purchase supplies. Okay? And the last thing that comes directly out of the start is going to be, and it has an arrow coming out of start going directly to hire DJ. All right, so we've got the first three activities done: purchase food, purchase supplies, and hire DJ, and they come directly out of start. So what's the first activity that has a prerequisite activity? That's prepare food, and it comes right after purchase food. So I'm going to move this prepare food right up here next to purchase food, and then place an arrow out of purchase food to prepare food. Okay? Next prerequisite activity is decorate dance hall. So let's move this down. It actually comes out of purchase supplies too. So I'm going to put it right next to decorate dance hall. And they both come directly out of purchase supplies. All right, and then that's everything. Everything we have is listed. So if we have everything listed, anything that ends a pathway goes directly to finish. So I'm going to make pathways to finish from all of these activities. And that includes hire DJ. I'm going to change the type of arrow though. But I'm going to change it to a dotted arrow. Okay? So, because it goes behind them all. You see that? Now it's behind there, but it works. Okay? All right, now we have a completed activity chart. We'll refer to it as we move along on the next couple questions. There's 4 questions left on the review. Which non-critical activity could be delayed by 5 hours without affecting the minimum completion time? Well, what is the minimum completion time? Let's look at it. All right, we're going to make a list of pathways. All right, first pathway is the top pathway. Purchase food, which is 1 hour, plus purchase or prepare food, which is 4 hours. Equals a total of 5 hours. All right, next pathway, purchase supplies, which is 3 hours, plus decorate dance hall, which is 5 hours, which equals 8 total hours. All right. Next pathway, purchase supplies, which is 3 hours, plus purchase or decorate school, which is also 3 hours, so a total of 6 hours. Last pathway, obviously, just hire DJ. That's a total of 1 hour, which equals 1 hour. All right. So what is the longest pathway? Obviously, it's going to be this 8-hour pathway. The minimum completion time equals 8 hours. All right. Which non-critical activity could be delayed by 5 hours without affecting the minimum completion time? Okay, first of all, we need to determine what are the critical activities. Critical activities are the activities that fall upon the pathway that has the minimal completion time. So that's purchase supplies right here and decorate dance hall. All right. So we're adding 5 hours to some task. If we had 5 hours to purchase food, that would make it 6 hours. 6 plus 4 is 10. It would actually increase this by 2 hours. The minimal completion time would be affected. Same thing if you did it to prepare food. You would actually end up adding 5 hours to 5 hours, giving you a total of 10 hours. All right. Obviously, we can't do it on this pathway because that is the minimum completion time. But how about purchase supplies to decorate school, which is 6 hours? If we had 6 hours to 5 hours, we have 11 hours. So it doesn't matter which one you do. This is a critical pathway. You couldn't do it anyway. It's a critical activity. It's one of the activities on the critical pathway. A decorate school, if you added 5 hours to it, 8 plus 3 is 11. Now that would increase it by 3. What about this pathway right here, just the higher DJ? If we add 5 hours to this, it would only equal 6. That would not delay the minimal completion time of 8 hours. So your answer for that is higher DJ. Which activity, if delayed, would delay minimum completion time? Any activity that delays the minimum completion time is called a critical activity. So those activities are purchase supplies and decorate dance hall. What's the minimum completion time? We've already answered that. That is 8 hours, remember? Now, here's a cool one. If an additional person placed on any task reduces the completion of that task in half, how long will the minimum completion time be affected if an additional person were placed on the prepare food task? Okay, so let's look at this graph. Prepare food task. If we change this and moved it and reduced it in half to 2 hours, that would change this pathway here to, look at that, 2 hours, making this reduce from 5 to 3. The minimum completion time still remains 8 hours. It does not change the minimum completion time at all. It doesn't even affect it in the slightest bit. The minimum completion time remains 8 hours. Okay? All right, so that's the review, folks. Can't tell you and stress enough that you need to take care of yourself, take care of the people around you love. I always end my things with be blessed, be a blessing. I want to go one further. Be blessed, be a blessing, and bless your family. All right? Y'all take care. Peace out.